Hello, algebra students. It's Coach Sharp again. Today's video will be concentrating on functions. Again, make sure that you have your guided notes out. Make this much easier as we go through. Fill in your guided notes, and then if you don't quite get something, then of course obviously you can stop the video and rewind, replay, and then you'll have it. To start off with our learning target, what we want to be able to do when we get finished is I can demonstrate understanding by recognizing a function assigns each domain element to exactly one element of the range. And that's important that it's each domain. Remember that the domains are the group of X, and it matches each one of those X's with exactly one element of the range, and the range are all of the Y's. All right, so a couple definitions. A relation is nothing more than a set of ordered pairs. That's it, just a bunch of ordered pairs. And you know that in our ordered pair, we usually have a parenthesis. And I don't know why I can't make the right-hand side look like the left-hand side. But our parenthesis has a comma on the inside, and whatever number is in here is our X value, and whatever number is in here is our Y value. All right, then we talk about a function. A function is a relation, so that means it's a set of ordered pairs for which each value from the set of first components, X's of the ordered pairs, is associated with exactly one value from the set of second components in the ordered pairs. Again, like before, each X can be paired with only one Y. Sometimes students will say that we can have no repeaters in the X. So the X cannot repeat unless it's the exact same pair. So the same X can be paired with the same Y, but X cannot be a repeater. Then again, we talk about the domain and the range. So the domain are all the X's, and the range is all the Y's. We said that just a minute ago on the previous screen. Okay, so working definition of a function, it's an equation for which any value can be substituted for X that results in exactly one value for Y. So most of the time, not always, but most of the time, we're going to have Y equals something X. Obviously, we can have a plus or a minus out here. We can have some numbers out here. But for any X that we put in here, we can only get one value of Y. So let's look at this where they say consider. On the left-hand side, we're going to take this equation, and we're going to substitute X equals 2. So wherever we see an X variable, we're going to put in a 2. So when we substitute, we're going to have Y equals 2 squared minus 5 times 2 plus 3. Now notice I put parentheses around that 2 that's being squared, because if that happens to be a negative number, we must, if we're going to type it in our calculator, put parentheses around it in order that the calculator gives us the correct answer. So when we figure this out, if we do it with pencil and paper, we have to do our exponents first. So 2 squared is 4, and then we multiply. Negative 5 times 2 is negative 10. And now last, we're going to do our addition or subtraction from left to right. So 4 minus 10 is negative 6, and negative 6 plus 3 is negative 3. So we put in one value for X equals 2. We got out one value for Y. Y equals negative 3. And then most times we'll write that as an ordered pair. So the 2 comes first because it's X, and negative 3 comes second because it's Y. Now the second example over here, they kind of look a little bit different. However, they're just the same. This is where we do f of x like that. That's called function notation. So that tells me, hey, this is a function, because they used function notation. There's no difference. F of x and y for us is the exact same thing. When we write our ordered pairs, we're going to do just like we did over here. So if we substitute in just like we did on the left, you're going to see that the only change is instead of writing a y right here, I write an f of x. I'm still replacing the x with a 2, so I have 2 squared. I'm replacing the x with a 2 as well here, so negative 5 times 2. And the plus 3 is just plus 3. And so when we do all that work, just like we did a minute ago, we, of course, get the exact same answer. So all this is doing is it's showing you that y and f of x are the exact same thing. And in this case, again, we substituted x equals 2, so if we do our ordered pair, the x comes first, and the f of x is the same as y, so it comes second.